The more digitalized the world is, the more human we must become. Welcome to the Researchers' Night, or morning, at Arcada University of Applied Sciences. So the world is increasingly digital, and it affects all of our lives and all societies. And our job as educators and researchers is to make sure that we always keep the human element at the fore. But what does it mean to be human? For 25 years already, Arcada has educated people for vital skills in society. Engineers, nurses, business experts, IT experts, social workers, cultural workers, and others. And we are very proud to, through our research-driven education, focus on creating a rewarding and sustainable life for current and future generations. But what do we mean by this? Here is where the human comes in. So our aim is, on top of core competencies in our fields of education and learning, to offer what we in Swedish call bildning. And this is a bit more than education. It's culture, it's cultivation, a composition of knowledge, critical thinking. The philosopher Jonas Salskog writes that the digital society needs building, and it needs building that hurts. Building that hurts. Why does it hurt? Well, it hurts because it's painful to question your own convictions. And it hurts because it's difficult to understand the context between various phenomena in the world. Building challenges our understanding of ourselves through perspectives that make the familiar strange, and sometimes challenges our norms and our values. So let me give you an example of how we, through our research, create this building. Ever since the birth of computation, we have placed a lot of hope on the power of computers and what we call artificial intelligence. We expect AI to bring significant benefits to society: efficiency and productivity, dealing with global problems such as climate change, poverty, disease. And as I said, these technologies are increasingly shaping our societies, and they have a huge impact on our daily lives. But unlike the great hopes we put on technology earlier, we now know that they also produce multiple ethical, societal, and legal issues with undesirable impact. They can discriminate us, they can threaten the society, they can threaten our health, and they can manipulate us, to name a few potential negative consequences. And for these reasons, we focus on the human aspects of AI systems. This doesn't happen only through core learning of coding or core learning of health sciences, or engineering, or business, or sociology. This happens through a cross-pollination of various fields. And it happens through an active collaboration with companies and organizations around us. It happens through interdisciplinary research that's academically solid, and at the same time keeping the feet deep in the practice of everyday work and life. This is what we do at Arcada. Let me give you an example of our research. So we're creating a health tech hub with the idea of bringing together actors and partners, both from the technical and the healthcare sector. For instance, here are some of our engineers doing research on computer vision technology that can help in physiotherapy. And at the same time, researchers in physiotherapy assess the usability of the technology from the physiotherapists' and the end users' perspectives. And to give even more understanding, we bring in potential vendors who assess the economy behind this, and perhaps other engineers to see even more into the AI technology, sociology researcher to assess the social and psychological challenges with this technology. And we do this because we know that science and technology do not by themselves give solutions to challenges in society. We need the human drive, and we need innovations that can be tested and adjusted quickly. Why is this building? Well, it's building because it forces students, teachers, researchers, and collaborators alike to change perspective. It forces us to challenge our core beliefs on what works and what's sufficient, and even sometimes what's right. And it makes us learn through co-creation. So our purpose is not only to produce employable people or to augment the present spirit of time. We want to offer building, sometimes even building that hurts. That is not only fun or useful for the career, but something that we need in order to become critically thinking individuals and societies. The motto of Arcada's fundraising campaign is, "The future is not what you imagine it to be. It is often better." We cannot know how we will make it better, but by embedding our research in everyday life, we have a good chance of getting there. Now, I would like to introduce you to our keynote speaker, Professor Roberto Zicari. Roberto Zicari has a long history as professor in database and information systems, earlier at the Goethe University in Frankfurt, and now as adjunct professor with the Seoul National University and with us at Arcada. He is an internationally very recognized expert in the fields of databases and big data, and he's also a pioneer within defining processes to assess trustworthy AI in practice. So Zicari's initiative to start dealing with the practical assessment of AI systems from many angles has led to a great international research initiative called Z Inspection. And we at Arcada have also started these assessments of trustworthy AI. And we are very happy and proud to have Professor Zicari as our mentor and our coach. Please, Professor Zicari, the floor is yours.
Thank you very much, Enrique, for the very kind introduction and also for the invitation for me to speak here. What I'm going to present is basically the work that we have conducted in the last 3 years. And as Enrique was saying, the title is mentioning, we're talking about artificial intelligence. And basically, how can you assess if whatever they use of this AI is trustworthy? The word trust is embedded in this title, because at the end of the day, it's all about new technology and people using it for making decisions, or hopefully improving existing situation. And so, as everything that is new, there's also an opportunity, but also a challenge. And this is really quite nicely mentioned by one famous colleague in the United States, that is basically saying, well, artificial intelligence has the potential of helping us as never before. And here is the important sentence: as long as we manage to keep the technology beneficial. The problem is, how do we know when the AI system is beneficial or not? There's been a lot of work by policymakers, governments, and public organizations, and try to give guidelines of how an AI system should be designed or what are the consequences, but very little work in practice. So basically our work, and including several researchers also by Arcada, so I'm quite glad to mention that is an international initiative, and since I'm affiliated now with Arcada, I also been involved in some of the researches here locally. We've been really working inspired by both theory and practices. So it's like a learning by doing, which fits very well the motto also of the university. Basically, when we look at an AI system in whatever domain, we need to consider the entire so-called life cycle, because that's important. So life cycle can be classified broadly in 4 areas. There's a design phase, mainly done by engineers that are sitting together, aiming at an AI system for some purpose. Then there is a development phase where from the design you end up start coding and possibly redesign by having some feedback to arrive to a point where you have deployment. And this is key. When at a certain point, somebody has to make a decision: do I deploy what has been done before into real production? Well, deployment could be in a hospital. It could be in a government. It could be in justice. It could be in any place where the people are the key. So AI might have then a role. And very important, which is sometimes forgotten, we need to monitor the AI system over time. Because, one of the characteristics of AI is possibly learning by situations, and is changing. So what maybe was actually working quite nicely at the very beginning, it might not work very well at the end. And we know this, we don't have to look at the AI. If you think of regulation, when you have a car, you have to bring a car to inspection every 1 or 2 years, because somebody made a regulation that you want to assess the safety of the car. So somebody has decided to how often you need to bring the car, who is supposed to assess if the car is safe, and what they are checking, the lights, the engine, stuff like that. Interesting enough, if you attest the car, you don't really attest the driver nor the infrastructure. So you could have a perfectly safe car driven by a perfectly unsafe driver, or a perfectly unsafe infrastructure. So that's the interesting thing. You'll see that AI is much of a technology like AI, is the key to include the full community of stakeholders. Now, interesting, because this is unexpected. I think this is referring to the quote that Enrico mentioned. It might actually bring discomfort to have a philosopher or to have a social scientist or behavioral psychologist working with medical doctors and engineers, because first of all, a lawyer, because they don't speak the same language, they have their own silos. But if you look at it from another perspective, and representative of people like patients, if it's in healthcare or other community, it will bring different viewpoints, which is normally not done as a default for all kinds of reasons. So what we've been doing is we have been working with best practices. What I mean with best practices, where we have really looked at AI system in real application. And we had 4 cases. Obviously, I don't have the time to go through all the 4. But just to give you an idea, when we started in January 2019, we assessed a product that was an AI device for predicting cardiovascular risk. With this assessment, we understood the complexity of what does it mean to give recommendation to engineers whether this product is trustworthy or not. And we learned a process that I briefly introduced. With this process that we learned, we applied to 2 large use cases that are public. This one here, I will spend some words just to give you a feeling of what it is. We've been working with the city of Copenhagen in Denmark, and you'll see that they have used AI as a supported tool for recognizing so-called cardiac arrest in emergency calls, so 112. I'll spend some time on this case because I think it will give you a very concrete example. I will not have the time to go through the other 2. So here you have a system already deployed, and medical doctor asks us to assess the implication of this use. Here, in this other case, we've been working with engineers in what we call co-design. So in early design phase, they were actually developing a prototype for an AI system that was able to help dermatologists detect skin lesion cancer. This has been also completed and is in the experience of working together with engineers. And now we're currently working on a very large case where we are working with a hospital in northern Italy where engineers and radiologists have been working together to have an AI system that is basically helping radiologists predicting the degree of lung compromise on COVID patients. As I said, I don't have the time to go through all of that, but I'll spend some time on someone. Goal of making an assessment for an AI system. Well, basically, you have to decide on trade-off, if there are. It could be that at the end, the use of the AI system is appropriate. So if that is appropriate, then you're giving a green light. But it could be that, you're assessing for all kinds of other reasons. That's why you cannot have only technical people or ethical people or medical doctors or policymakers making a decision on their own, because there will be several viewpoints. It could be that you need to ask for remedies if there's some risk identified. The word risk is very important, especially in nowadays, because governance, so lots of government are actually defining how much risk you have for certain class of application of AI. The European Commission has also defined a proposal law for that, which is risk-based. How do you mitigate risk is very important, not only for the people, but also for all kinds of reasons, liability issues, image issues, and if certain kind of AI is meant to be not really reasonable, you have to have the ability to redress. Redress could be of two kinds. Either you are forbidding the use of AI, and the European Commission is actually going in this direction with face recognition technology for the high sensitivity. Or if you discover that a particular AI system that was implemented, maybe in good faith, and deployed is discriminating people or is doing injustice or is against human rights, you need to be able to redress, so take it out. Of course, the problem is if you have already done damage, you have already harmed people. Now, this is general. Let me deep down into a real case that we've been working for half a year. This is together with the so-called Emergency Medical Dispatch Centers, EMS, of the city of Copenhagen, which is a set of hospitals managing the emergency, health-related emergency call 112. Normally, when you call 112, in the States it would be 911, in Europe it's 112, there would be people answering the phone. These are so-called medical dispatchers that are mainly medically trained people, nurses, paramedics, not necessarily doctors. And they will listen to the call, and basically, in case they understand there's an emergency, they will do a so-called triage and maybe send an ambulance on and send the medical doctors on site with an ambulance. So unfortunately, we're all familiar with that. Here is the specific problem that they have. They discover, at least in Copenhagen, that in the last years, the system, so the people answering the phone, has failed to identify approximately 25% of cases of what they call out of the hospital cardiac arrest. And basically, for those of you who don't know what is a cardiac arrest, or we might be confusing a heart attack with a cardiac arrest. Basically, a cardiac arrest means that the electrical signal of the heart stopped working and the heart is not working. The person is technically dead. But in the heart attack, you can still talk and articulate. The person who have a cardiac arrest is basically dead. So if he's on his own at home, he's unfortunately probably going to die. If there is somebody in the house, a so-called bystander, it will call 112 and try to explain on the phone that there is a problem. The thing is, if the person, the dispatcher, are able to recognize by the conversation that there is a case of cardiac arrest, because a person can be unconscious for many reasons, like could be poison, could be in anything. But if you understand for what the conversation, he can actually give by phone an instruction of doing a cardiopulmonary resuscitation. You see, that's basically the situation. This is the person who had a cardiac arrest. The person in the family is shocked, calls here is 911, but it's 112 in our case. And then on the phone, if the person by the conversation understands that what is describing, what she's describing is a case of cardiac arrest, he can instruct to do certain things, check for breathing, and do a cardiopulmonary resuscitation, which basically place your hands on the center of the chest and push hard and fast about twice per second. And hopefully resuscitating the person. If this person has no idea of what to do, he has to have instruction over the phone. If that's not happening, you might lose time, and if within 5 minutes you don't do a reanimation, you might damage the brain. So even if the ambulance arrives, it could be too late. There's a liability issue, which is extremely important. Who is responsible if something goes wrong? Well, the medical dispatcher are liable in case they didn't follow a particular protocol or they were not available during the call. So there's a lot of stress. So the medical doctors who own the data, so that's remarkable, thought that maybe with help of AI, they could have a better solution. So they worked together with a startup of the University of Copenhagen and tried to give them specification for them, so smart researchers, people with PhD coming up from research, to do an AI, so a machine learning, that could be listening to the call and basically by the pattern of communication, recognizing that there was a cardiac arrest. So the thing that they were thinking was like that. Somebody is calling 112, this person has a cardiac arrest, the dispatcher is answering the phone, and an AI system like an Alexa is listening to the conversation. Remember that listening to the conversation really means for the AI to look at patterns of 1 and 0, because the audio file can be transformed into numbers. The AI does not understand anything except he understands the patterns. But if he has been trained with audio files where there were cases of cardiac arrest, he might signal earlier than the dispatcher a case of cardiac arrest. And that was the idea, that this would help the dispatcher when he's talking and he's under stress. Oh, look, there is a high probability of cardiac arrest. So the dispatcher maybe didn't pay attention, then he's actually instructing the person to do cardiopulmonary resuscitation. So before embarking in deploying into real life, they did actually remarkable 2 studies. One was to look at the AI system, how it performed in a so-called retrospective study. Well, retrospective study, as the word is saying, is actually something that has to do with the past. So basically, since the emergency service owns the data, they basically gave to an AI 100,000 and something audio files of emergency call in a particular year, and they knew exactly which of this call was actually a case of cardiac arrest. And they benchmarked if the AI was able to detect all of these cases. And the AI system performed very well. So it was very so-called accurate. Then they did another interesting study. They did a randomized clinical trial, which, by the way, not everybody does. So this is remarkable that they did. So what they did, they took a group of people, and in total they have 5,000 real emergency calls. And there were 2 groups of people. One group of people, the dispatcher, without the AI, listening to the call and making decision. And the other group of people, with the AI, there was alerting the medical dispatcher in case of suspected cardiac arrest. Interesting enough, they even published a paper. There was no significant improvement in recognition of out of the hospital cardiac arrest during the call where the AI was involved. So somehow, the problem was that sometimes the machine, so the AI, was thinking, well, obviously it doesn't think, but it was predicting a cardiac arrest when there was not cardiac arrest. So in technically speaking, it was false positive. So it was very accurate. It was always detecting a cardiac arrest, but it was too much detecting. And somehow, then you have the first important decision to be made. Somebody in the organization that saw the 2 studies, so the AI alone performing well, the AI in a control study with people don't pay attention, don't trust the system. So what would you do? Well, you see, this is a very interesting situation. How do you make a decision based on limited information? So in their case, the head of emergency medical dispatch center and probably some ethical board authorized the use of the AI system, even if the control study was mentioned, there was no benefit. So now the AI system is in production since fall 2020. So if you call, this is actually how it looks like, if you call 112 in the city of Copenhagen, this is a medical dispatcher, and he has all the display, this is the helicopter, and this is the AI. So you see it's like an Alexa, and it's operational. So then the key question was, why dispatcher do not seem to trust the AI system? And most importantly, is the AI system helping or harming people? And here, there is no law that forced them to do anything. So we decided together with them to conduct a self-assessment. That was conducted jointly by our team of independent experts from all over the world and different backgrounds, together with the prime stakeholders, all the medical doctors. We did not involve the company in order to be neutral. Our motivation was really to help them to understand whether the AI was doing something good, or if in case there were risk of harming, to improve it. So for doing that, we've been using this process that we have developed. Some of the Arcada research were part of the core team from the very beginning. In particular, Magnus Westerlund, who was a senior researcher, lecturer in big data, was part of the core team from the very beginning. So I'm really happy because then we started to have even a localized group of people at Arcada. But this is an international initiative. And we identified, the focus was to look at 4 issues: ethical, technical, legal, and domain-specific issues. So how did we assess this? I have obviously not enough time to go very much into detail, but basically what we do, we use a holistic approach. So rather than using a monolithic one-view approach or static checklist, like did you do this, yes or no, you're good, you're bad, we have tried to come up with a orchestration process that is helping teams of skilled experts to identify all the implications of the use of an AI within a context, and basically then verify some of the claims. So in a nutshell, we define something that we call Z inspection, which is basically 3 phases. There's one phase where you basically define a team of experts and what you want to assess, also the boundary and the content. The second phase is the assess phase, where you basically look at the AI system from various angles. We call it socio-technical scenario. And basically with that, we can understand why the AI system is so designed or so implemented. And then this includes a phase of identification of issues. And you might have philosopher talking to medical doctor, to a behavioral scientist, and medical doctors or general medical doctors, specialists or engineers. Discussion will never end. So we need a consensus process that is forcing people to speak from an open vocabulary, their own language, into a framework, which is a common framework. And we'll be choosing a framework that the European Commission has defined, called Trustworthy AI framework, where we map all of these concerns, then we validate some of the claims, and finally, either we give recommendation or show some ethical issue or tension that cannot be solved. And basically, that's how we do it. In order to arrive to a consensus, we decided to use a framework that is being defined by experts from the European Commission, where they define some metrics, because we need to have some kind of way of measuring to what extent an AI system is trustworthy. Extremely difficult, because here we're not only talking about the technical part, we are talking about if it's lawful, so respecting law, if it's ethical, extremely difficult to give definition, if it's technically robust. And so basically, this is rooted in 4 ethical principles, rooted in fundamental rights. The first 3, respect for human autonomy, prevention of harm, fairness, are typically what you find in medical bioethics. And they invented one called explicability, which is even a new word. And there might be tension between this. It could be that you cannot explain something, but it's very fair. And so you can have them both, or you have something that is a tension between how decisions have been made. So it's not a perfect way to assess because these principles are very general. So they try to give requirements. They give 7 requirements. There's a mix of technical and non-technical requirements. And these are the requirements: human agency and oversight, technically robust and safety, which is the technical part, privacy and data governance, transparency, which is really the new part, because most of the time AI systems are not transparent and are not explainable. And then you have diversity, non-discrimination, fairness. Again, here, this is extremely general because fairness can have several different definitions. Society, environmental well-being, also extremely difficult to measure it, and accountability, which is really the part on risk. So what are the lessons we learned? That first of all, this formed a team of interdisciplinary experts, and this was a dynamic process. So you add experts with different skill and background. But the lesson learned, the choice of the experts have an ethical implication. You have to be very careful what kind of people you bring in. And the other lesson is that you need to consider the software in the context. You never only assess the software. It's never in isolation. It's have to do with processes, with people, how decisions are made, and the boundary, we call it an ecosystem. So here I might end up maybe assessing a part of a hospital, not only the software or a division. So to do that, you can actually use a social technical scenario that can be used both for design or for a system that's already been implemented. And basically you bring on a table or on Zoom, depending on the situation. At Arcada, we did an interesting workshop a couple of days ago, live. So it was my first workshop live after 2 years, where we took experts and they analyzed the design implication of a particular system. And basically what you're doing, you describe the aim of the system, who are the actors, sometimes called the stakeholders, and their expectation and interaction. And this is already something that sometimes engineers are not ready because they only thought in one angle. The processes where this is used and the technology. And the lesson learned is that if you have a number of people with different background, they need to be able to describe what they think is an issue with their own words. So we use an open vocabulary, which sometimes means that either the people don't understand each other or they have misunderstanding. But in that way, you are able to have different angles. But then a consolidation process must be put in place. Otherwise, you don't go anywhere. And in order to understand whether there is an issue or not, you also have to have in place a process for developing an evidence base. And that's very important because when somebody claims something, there should be an evidence. Now, what are the lessons learned? The lesson learned by doing real cases is that there is a tension sometimes in building an evidence base, domain specific, because, for example, different domain experts disagree. And if they disagree, who is qualified to give a strong evidence? So is that a dermatologist more qualified than an evidence-based colleague in public health? They might disagree on what is good and what is bad. And when you come to system, you might have trade-offs that you need to choose. You could have a system that is very accurate, but you cannot explain. So, and if you are insisting on explicability, you might have a system that is less accurate. So that's also something that you can come up as information. And back to our use case, just to give you in the last couple of minutes, some of the idea. One of the biggest risks for this use case, the 112, is to see whether a correct dispatcher, so correct dispatcher means is experienced, who knows something, is actually following a wrong decision by the AI. Well, what it could happen that he's trying to give instruction or animation on the person doesn't need it. So that could be bad, but also there could be lack of trust. It could be the dispatcher will not sufficiently pay attention to the AI output. Why? Well, that's all has to do with the interaction between the decision between people and machine. That's basically one of the requirements of human agency and oversight. How do you make decision now that you have a system that is automated? It's not making the decision, but it's giving you a recommendation. And also, since the system was very accurate, but it was also too much thinking that there is a possibility of a cardiac arrest, even when it was not, technically too many false positive. It could be that the dispatcher didn't trust it because they thought, oh, it's always saying there is a problem. And also the other important thing that we discovered that there's a lack of explainability. The AI system was not transparent. There was no explanation whatsoever given to the dispatcher why the system is predicting a cardiac arrest. And so to some extent, either you trust the black box or you don't. And also the way it was communicated is very important. Here is also something that we discovered that this system was, because if some of you is technical listening, he obviously knows that an AI system needs to be trained and tested. This system was trained and tested using audio files of patients or people calling in the city of Copenhagen, most of them native Danish speakers. The problem is that when the system then live receive a call from a non-speaking Danish person, or a Danish person speak with a heavy dialect, or a foreigner try to speak Danish, that wasn't very accurate. And here, there's a risk of discrimination that the system might not understand that there is a cardiac arrest because the way you speak. So this is something that they didn't even consider. So that's a high risk. So basically what we did after 6 months of assessment, and there is a report that we published, so it's publicly available, we gave recommendation to the key stakeholders what they could do in order to verify some of the claims of some of this issue in order to move forward and improve the situation. We are going to continue working with them now, resuming work in the fall, and it will be extremely interesting to see what they do with our recommendation. If some of you are interested to know more, we have a website with full of information, especially all these cases. There is a process, and there are the 2 reports, the full reports of the case of 112 and of the co-design. And we also have some preliminary information on the COVID use case that we are currently working. With that, I finished my presentation here. Let me stop the sharing, and I'm happy to answer questions in case there are any.
Thank you so much, Professor Sikari. This case is extremely intriguing, and also it's quite a big and important case, saving lives. It gives much ideas of what this kind of assessment can do. But just, we have 2 minutes. So I'd like to ask you, if somebody now got interested in, has some kind of a AI application that he or she would like to assess, what would be the first steps to start this process?
Well, this is a very good question. So it could be depending on if they are developing themselves, the AI system, or if they have a company or a university startup that develop for themselves. So if they are in the phase of early design, it would be important to have a team of different specialists, analyzing some of these issues. They can obviously ask Arcada if they want, but if it's in some other place, they can try to have maybe neutral external people, or even internal people. If it's already deployed, that's another story. Then it becomes like almost an audit. So having said that, I think everybody that wants to use an AI system would be better off to have this assessment done before the decision to deploy. So in this case, the medical doctors told us, if we only knew before, 2 years ago, what we discover now together, we will have probably done differently.
Thank you. That's important. And I think we will see more of these assessments in the future. So thank you for your presentation. Very glad to have you here, and I'm sure we will see more of you. And to all of you who have been listening and watching, thank you for participating. And if you want to read more about Arcada's research, please go to our website on arcada.fi/research. Thank you and have a good weekend.
Thank you.